There is a misconception so deeply woven into the way human beings perceive the physical world that most physicists themselves rarely pause to confront its full psychological weight. It is not a casual misunderstanding. It is a foundational error in the intuitive framework every single one of us carries from birth, reinforced by every step we have ever taken, every road we have ever traveled, every night we have ever stood beneath a sky full of stars and felt small. The misconception is this: distance is real. Distance is fixed. Distance is the universe's way of telling you that some things are simply, permanently, irreducibly far away. And the mathematics of 20th century physics dismantles that belief with a completeness that should genuinely stop you in place. We grow up internalizing a model of space that feels as solid and objective as anything we know. You are here. That galaxy is there. Between you and it lies a span of roughly 13 billion light years, a number so enormous that the human mind essentially rejects it. 13 billion years of light traveling at 300,000 kilometers per second, every single second, without pause, without deviation, without rest. And even after all of that, the light has only just arrived. Surely that distance is among the most concrete, most undeniable physical facts in the observable universe. Surely nothing in physics could reframe that number as something less than what it appears to be. But here is precisely where the geometry of space-time begins to peel apart our assumptions layer by layer. To understand what is truly happening, you need to hold a specific image in your mind. Imagine you are standing in a long corridor, and at the far end of that corridor there is a wall. You begin walking toward that wall. As you move faster, the distance between you and it begins to decrease. That much is ordinary. That much is intuitive. But now imagine that as you accelerate further, something far stranger begins to occur. The corridor itself, the physical length of space between you and that wall, begins to compress. Not because the wall is moving toward you in any conventional sense, but because the spatial dimension in your direction of travel is mathematically shrinking as a direct consequence of your velocity. The faster you move, the shorter the corridor becomes, not from the perspective of someone watching you from the side, but from your own perspective, from the perspective of the moving frame itself. Now push that velocity all the way to the speed of light. The corridor has zero length. The wall is not approaching you. The wall is already there, touching you at the very instant you begin your journey. There is no journey. There is no distance. There is no gap left to cross. This is not a metaphor. This is what the Lorentz transformation, one of the most rigorously tested mathematical frameworks in all of physics, tells us about the geometry of space when an object moves at the maximum velocity the universe permits. Let me be precise about the mathematics here, because the precision is what makes this so astonishing. In 1905, Albert Einstein constructed special relativity on two foundational postulates. The first was that the laws of physics are identical in every inertial frame of reference. The second was that the speed of light in a vacuum is constant for all observers, regardless of the motion of the source or the observer. From these two postulates alone, a set of coordinate transformations emerges, first derived by Hendrik Lorentz, that describe how measurements of space and time differ between reference frames moving at different velocities relative to one another. The Lorentz factor, typically written as the Greek letter gamma, is the mathematical engine at the heart of all of this. It is defined as 1 divided by the square root of the quantity 1 minus the ratio of the object's velocity squared to the speed of light squared. When velocity is small, gamma is very close to 1, and the corrections to Newtonian expectations are negligible. But as velocity approaches the speed of light, that ratio approaches 1, the denominator of the Lorentz factor approaches 0, and gamma itself approaches infinity. And it is this behavior at the limit that contains the most profound physics. Two phenomena emerge directly from this mathematics. The first is time dilation. A clock moving at high velocity relative to a stationary observer ticks more slowly, as measured by that stationary observer. The faster the clock moves, the more its ticking slows. At the speed of light, a moving clock does not merely tick slowly, it does not tick at all. Time, for an object moving at the speed of light, stops completely, not approximately, not nearly. Precisely and mathematically stops. The second phenomenon is length contraction. An object moving at high velocity in a given direction is physically shorter in that direction as measured by a stationary observer. More significantly for our purposes here, the distance between the moving object and its destination contracts in the reference frame of the moving object itself. As velocity increases, that contracted length decreases. At the speed of light, the contracted length is zero. The distance between origin and destination, measured from the perspective of the thing doing the traveling, is not vast. It is nothing. Now bring this back to light itself. A photon has no mass. This is not an approximation. It is a precise statement about the fundamental nature of photons as described by quantum field theory. Because a photon has no mass, it is not constrained the way a massive particle is. For any particle with mass, reaching the speed of light would require infinite energy, which is why massive objects can approach but never reach that limit. A photon does not approach the speed of light. It travels at the speed of light from the moment it is created. It has no other option. It has no rest frame. There is no coordinate system in which a photon is stationary. What this means when you apply the Lorentz transformation to a photon's frame of reference is something that deserves to be stated with absolute clarity. From the photon's frame, the spatial dimension in its direction of travel has contracted to zero. From the photon's frame, no time elapses between the moment of its emission and the moment of its absorption. The photon that left a galaxy 13 billion light-years away emitted from a star in the process of forming when the universe itself was less than 1 billion years old, and the moment that photon reaches your eye tonight as you stand and look upward at the night sky, those two events are not separated by 13 billion years of elapsed time. They are not separated by 13 billion light-years of traversed space. From the photon's mathematical frame of reference, those two events are perfectly simultaneous. They occur at the same point in space. They occur at the same moment in time. The birth of that photon and its contact with your retina are, in the only frame of reference belonging to the photon itself, a single event. This is the point where the intuitive mind tends to resist. It feels as though we are speaking loosely, as though we are indulging in a kind of rhetorical exaggeration for philosophical effect. But we are not. The mathematical structure of special relativity does not allow for a photon's perspective to include distance or duration. The metric interval between the emission event and the absorption event, calculated using the full spacetime interval formula, is precisely zero. Not small, not negligible, zero. In the language of spacetime geometry, we call such pairs of events light-like separated. Two events are light-like separated when the spacetime interval between them vanishes, meaning the distance in space and the distance in time are perfectly balanced by the factor of the speed of light, such that the net geometric separation is nothing. This is the mathematical condition that defines the path a photon takes through spacetime. Every photon in the universe travels along what physicists call a null geodesic, a path through the four-dimensional fabric of spacetime whose length is identically zero. Every single photon in the entire observable universe, traveling along a path of zero length. Now sit with the deeper implication of that. The universe we perceive from our particular vantage point as a collection of objects distributed across billions of light-years of expanding space is, from the perspective of the fundamental radiation that fills and connects all of it, not spread out at all. The photons carrying information from the cosmic microwave background, the oldest light we can detect, light that has been traveling for roughly 13.8 billion years, those photons did not experience a 13.8 billion year journey. They experienced no journey. Their emission and their detection are the same event, mathematically collapsed into a single dimensionless point in their own frame. This forces a remarkable conclusion about the nature of distance itself. Distance, as we experience it, is not a universal property of space. It is a perspectival property of massive observers embedded in spacetime. Because we have mass, we are bound to reference frames where time flows and where spatial separation between objects is real and measurable and enormous. Our mass is precisely the reason we perceive a universe that is 13 billion light-years across. It is the reason a journey to the nearest star feels impossibly long. It is the reason the cosmos seems vast and cold and unreachable. We are not observing the universe from the outside. We are embedded within it as massive, slow-moving objects relative to the speed of light, and that embedding creates the experience of distance. The galaxy you are looking at did not send you a signal from far away. The photon that connects you to it never traversed any distance at all. What you are experiencing as a separation across unimaginable space is, at the level of the physics itself, a localized interpretation produced by the geometry of your own reference frame. Consider what this implies about the universe as a geometric object. If we take seriously the Null geodesics along which all light travels, and if we take seriously the fact that these paths have zero space-time length, then in a precise mathematical sense, every event in the universe that can be connected by light is not distant from every other such event. The geometry of light does not recognize separation. It does not acknowledge the 13 billion light-years between the formation of an early galaxy and the surface of your eye. It moves through space-time in such a way that the beginning and the end are the same point. We tend to think of space as the stage upon which physics occurs. We picture the universe as a container, enormous and three-dimensional, and filled with objects at various distances from one another. Special relativity is asking us to recognize that this picture, while enormously useful for everyday life and for much of classical physics, is fundamentally incomplete. Space is not a fixed background. It is a dynamic geometric quantity whose measurements depend on the state of motion of the observer. And at the extreme limit of that motion, at the speed of light itself, space in the direction of travel ceases to exist as a measurable quantity. There is a further layer here that most presentations of relativity do not linger on. We have been discussing length contraction and time dilation as though they are independent phenomena, two separate effects that happen to emerge from the same mathematics. But they are not independent. They are two aspects of a single geometric reality. Space and time are not separate quantities that happen to both be affected by motion. They are unified into a single four-dimensional geometric structure called spacetime, first formalized mathematically by Hermann Minkowski in 1908. Motion through space and motion through time are not independent. Every object in the universe is always moving through space-time at the same total rate, the speed of light. When you are stationary in space, all of your motion through space-time is directed into the time dimension, which is why you age, why your clock ticks, why time flows for you. When you move through space, some of that fixed total motion is redirected from the time dimension into the spatial dimensions. As you move faster through space, you move slower through time. A photon moves at the speed of light through space, meaning all of its motion through space-time is directed spatially, with none remaining for the time dimension. This is not merely why time stops for a photon. It is why time stopping and distance vanishing are the same geometric statement. The photon does not experience distance because the photon does not experience time. And the photon does not experience time because all of its space-time motion is consumed by its travel through space. The vanishing of distance and the stopping of time are one and the same relativistic fact seen from two different angles. What this ultimately asks of us, as thinking beings who have spent our entire lives developing intuitions about space and distance and separation, is something genuinely difficult. It asks us to recognize that the universe we perceive is shaped as much by our own physical nature as it is by the external structure of reality. The distance between you and that galaxy 13 billion light-years away is not a neutral, observer-independent fact about the cosmos. It is a measurement that emerges from your specific place in the geometry of space-time, from the fact that you have mass, from the fact that you are moving far below the speed of light, from the fact that you are a slow, massive, time-experiencing observer in a universe that also contains massless radiation for which none of these categories apply. Strip away the mass, strip away the slowness, travel as light travels. And the galaxy that appears to sit 13 billion light-years from where you stand is not across the universe. It is here. It has always been here. The universe, for the fundamental radiation that threads through all of it, is not vast and dark and filled with distance. It is a single point. A dimensionless convergence of every emission and every absorption, every photon that has ever been created and every photon that has ever been observed, all of it folded into a geometry where separation does not exist and time does not pass. We are the ones who created the distance. We created it with our mass. We created it with our slowness. We experience the universe as enormous because we are too heavy to know it any other way. And that, perhaps more than any other single insight that